Hey everyone, welcome to your final week of calculus. This week's actually going to be pretty straightforward. You've kind of done most of the hard work, especially last week. Hopefully, last week went okay with all the Riemann sums and everything. This week, in our last week of new material, what we're going to be looking at is indefinite integrals and something called the net change theorem. We'll also be looking at something called the substitution rule, which is just a way to help us integrate easier. And then in the first section of chapter 6, which is the last thing we'll do, we're going to be looking at the area between two curves. So rather than like we've been doing with area where we go under a curve between that curve and the x-axis, we'll look at the area between two different curves. Each one is fairly straightforward, so I'm not going to spend too much time going over them. I think the notes online and the book will help a lot, and hopefully just having the general idea of what's going on will be enough to get you guys going. I try to make it a little easier this week since the final's upcoming and test 3, so it's a lot to study for. So getting into it, we have indefinite integrals, which are just antiderivatives. That's literally just it. Like there's no difference. So if you see an integral without bounds, so remember bounds are the two numbers on the top and bottom of that big S thing, our integral sign. If you come across an integral that does not have bounds, it's just asking for the antiderivative. So take the antiderivative like normal, put a plus c at the end, don't forget that. All right, and then you're done. The net change theorem essentially says that if you have a function and you want to determine how much that function has changed from one point to another, what you can do is you can take the integral of its derivative between those two bounds, and that will tell you how much it's changed. It's a little confusing when you say it like that. So usually the way I like to think about this is to put an example to it. So of course we have the position of something as a function, and if we take its derivative, we know from what we've done previously that that is the same as the velocity of that object. So if we have the position function of an object, we take the derivative, we get the velocity. Well, we can actually start with velocity. If we want to figure out how far something has traveled, all we have to do is integrate that velocity function from whatever 2 points or 2 timestamps we're interested in. So if I want to find how far an object moved between 3 and 5 seconds, what I could do is integrate the velocity function, get the position function, right, plug in my 2 bounds, and then I'm good to go. Now, one thing I want to make clear is this is called the net change theorem, and that's because it gives you the net distance. So for example, if I have a particle that starts here, moves this way a little bit, and then goes back, right? If I look at the net change, it started here and it ended here, so all I'm going to get is this distance. I don't get the fact that it traveled over here and then back. So if we want to find the actual distance, it's a really easy fix. All we have to do is take the absolute value of the function before we integrate it. And that's all we have to do. So you've dealt with integrating absolute values before, so I'll trust you are okay on the mechanics of that. And if you're not, you are completely free to talk to me, and I will gladly help you out with it. But if you were looking for the net change or the displacement, right, that is, right, just where it started and where it ended, then we can just take the integral like normal. If we want the distance traveled, so we want to know if it went that way and then this way and ended up there, that's when you have to take the absolute value. All right, so that's 5-4. 5-5 is our substitution rule. This is basically the reverse of the chain rule. So the way this is going to work is if we have an integral that's kind of complicated, but it looks like we have a composition of functions. All right, what we can do is we can substitute out the inside of that function. Right, so remember when we did a chain rule, we did outside and inside functions. So we can substitute out the inside of that function for u. That's why it's usually called u sub for short. And so we'll set u equal to something. We'll take the derivative. We'll get du equal to whatever the derivative of what we said it equal to is. And then we'll try and sub that back into the integral. Now it makes a lot more sense when you see an example. So the first couple problems of the homework are going to actually give you the substitution you need. So you can take that substitution, take the derivative, try and sub everything back in. And our end goal is to take all of our integral stuff, which is x stuff, right? It's all written in terms of x, and change that over into an integral that's all written in terms of u stuff. So you don't want to have u's and x's mixed. You want to have all u's, and you want to start with all x's. So we go from all x's to all u's. So if you get to a situation where you start with all x's, you make a substitution, you still have some x's floating around, we can probably make a better substitution. So if you run across that scenario, just try and find something different to substitute for. And this is really a trial and error thing. It's not something I expect you to be able to look at initially and say, oh, I know exactly what I need to say. U equal to, I know what I need to substitute. It takes a lot of practice. So do the homework, right? See if you can get a feel for what we're supposed to sub out, what makes sense. And if you get it wrong, try something else. It's as easy as that. It takes a while to develop the intuition. So don't worry if initially you're having trouble figuring out what the substitution should be. That is the hard part of the substitution method. So when you work on those problems, try and focus a little more on that so that the test and the final will be easier. 6.1 deals with the area between curves. And so what we have here is, rather than just, like I said, a curve and then the area between that and the x-axis, we have two curves and we want to find the area between those. And the solution to this is really easy, and you can actually draw out a picture and kind of see. If we take the integral of the first function, and by first I mean the top function, so the one that is on top when we look at our graph, we do the integral of this function minus the integral of that function. That's all it is. So that'll give us the area between, because the top function, if we go from here to the x-axis, is going to be all this area. The bottom function will be all this area. So we just take the whole thing and subtract out the part we don't want, and that gives us the part we do want. So integral of the whole thing, which is the top function, so the whole area is the integral of the top function, minus the integral of the bottom, which is the part we don't want, and that leaves us with the middle. So that's all you have to do. When you're looking for areas between curves, there's two things that are going to stand out. You were probably going to have to find the bounds in some problems, so you're going to have to figure out where the curves intersect. So if I have two curves, right, and I'll try and do this like this, you can see they intersect here and intersect here. You're not always going to be given those, and so you're going to need to be able to find those, and that's as easy as setting the two functions equal to each other and then solving for x, and that will tell you exactly where those functions are equal. The other thing you need to watch out for is figuring out which one is the top function and which one is the bottom function. Now, if you're given a picture, it's super easy, right? The one on top is the top function, the one on bottom is the bottom function. But if you are not given a picture, you're just given two equations, you need to figure out which one is on top and which one is on bottom, so you know how to subtract. Because if you flip the subtraction around, you're going to get the right number answer, but you'll get a negative sign where you're not supposed to have one, or the sign will just be different. So what we want to do to figure that out is, once we've found our bounds, pick something between those bounds. So say our bounds were from 0 to 2. I'm just going to pick 1. I'm going to plug 1 into both functions, and I'm going to see which one's bigger. So function 1, I plug in 1, and it gives me an answer of 6. And function 2, I plug in 1, it gives me an answer of 3. I know that function 1 is the top function because it's bigger. Right? So that's all we have to do in that scenario. And that's all we're doing this week. So really, once we have the Riemann sums and we're able to build up this thing called an integral, right? And then once we look at the fundamental theorem of calculus and see that integration is just the opposite of differentiation, then a lot of the stuff kind of follows fairly straightforward, because it's basically what you've been doing but in reverse. So like I said, antiderivatives are the same as indefinite integrals, and then the net change theorem, that's 5.4. 5.5 is just our substitution rule, so make sure you pay attention to what you are subbing and how you're choosing what to sub. And then 6.1 is our area between curves. So like I said, try and figure out what the top function is, try and figure out what your bounds are. Once you know how to do those two things, it's just taking two definite integrals and subtracting them. And that is all. So, of course, if you have any questions, please feel free to talk to me. I'd be happy to help out. You can email me or send me a message on Schoology. Both of those things are fine. Otherwise, I hope you all have a great week, and I hope studying for both the test and the final goes well. The test will be, just like we had last time, will be opened up Tuesday, Wednesday, and Thursday of this upcoming well, of the next week. And then the final actually starts, I believe, on Thursday, and the finals week is Thursday, Friday, and Monday. So what I think I'm going to do is I'm going to open it up on Thursday, and just let you choose the time you want to take your final. So the final is going to be like any other test. It'll follow the same format. It will just be on all of the material. So it will be a cumulative final. So you will have between Thursday and Monday of next week and the week after to take that. But anytime you want to take it during that window is fine. So if you have any questions, let me know. And otherwise, I will talk to you guys soon.